Okay, good. So the
Okay, let's get started here, everyone. Thanks for coming. This is not a normal part of Colloquium. Colloquium officially ended last week, but I'm very glad to have our speaker here for this quasi colloquium, more like a workshop. We'll see how it's going to go. But I'm very pleased to have Dr. Chris Brierley come visit us here. Chris is a professor at University College of London, and Chris is largely, I guess I would describe you as a climate dynamicist more than anything else, but Chris works on many different aspects of atmospheric science, ocean atmospheric coupling, modeling, and also heavily involved in paleoclimate and paleoclimate sciences. Chris got his, he went to undergrad in Durham and then went on to get his master's and PhD at Reading, if I'm not mistaken, working with Alan Thorpe.
Yep.
And then after that, Chris went on to do a postdoc at Yale, working with Alexei Fedorov on several aspects of tropical climate change and Pliocene-related climate change. And then after that, Chris went back closer to home to become a professor at University College at London. So Chris is going to be around. He's visiting for the next 3 weeks here. So if any of you would like to have a chat with him and to learn about climate dynamics or model access, Chris is the person to talk to. Where Chris and I really got to know each other, I think Chris is one of the few people I've seen do this really effectively, is not go to many conferences, yet have a very large network. And I think the way that Chris has managed to do that is by organizing himself a lot of these small workshops that gets together a lot of people. And I think Chris is one of the people who does that really effectively. And that's how we got to know each other back in 2014 at a variability conference that Chris organized at UCL. And we've kind of kept in touch on and off since then. I would really say that Chris's work touches on a lot of different themes, a lot of different time periods, including the Pliocene, the mid-Holocene, the glacial climates as well. So if any of these strike your fancy, I would definitely suggest taking advantage of the fact that Chris is here visiting us, and make sure you spend some time talking with him. Send me an email if that sounds interesting to you, and we can definitely organize something. So without further delay, I'd like to give the floor to Chris. Go for it.
Thank you very much. So I picked a really exciting title, saying a bit about what I've been working on recently, I suppose, and hopefully I can show you a little bit about what to do. I thought I'd start off by, but before I get into describing some of those boring aspects, I thought I'd start off a little bit saying a bit about myself and why I'm interested in that and why I think it's useful to know. So I'll start off by that, and then I'll get into some discussion of PMIP, which is an acronym you've got to be really careful with typing into Google, and explain a bit about that and what models are there and sort of what I'm going to be playing with Cal when I'm here. But I really want to get to know more about the department and to remember what not being burnt out and being excited about researchers. So I do want to talk to lots of people. And so I guess the first port of call is to start off when Carl said I did my PhD with, well, it was with Alan Thorpe, but I was doing something called perturbed physics ensembles for my PhD, which is where you really care about uncertainty in models, and you take a model and you intentionally break it a bit, so that it's spread, so that you've got more than just one model and it spreads in that aspect. And so I've been doing a bit more of that, and I'm interested in that. I've recently been looking at regional climate models. There's the UK Climate Prediction 18, and so thinking about that compared to other regional models. explain what the plot is in a sec. But that comes with ensemble post-processing or observational constraints is, I suppose, another way of saying it. And then I've also supervised a couple of PhD students in statistics, thinking about how you deal with uncertainty in observations. And one of the things that I've thankfully got out of at the moment is I'm being involved in a proposal with the Climate Research Unit to update one of their data sets by thinking about observations and the uncertainty in observations. So I'd quite like to talk to that. This particular one is, so we've got two regional climate models. There's the UKCP, which is the Met Office's official climate models for the UK. And then the Euro Codex is a more collaborative CMIP5 style thing. Again, we've just stripped out the UK, and this is at a particular time frame. And you can see that these two ensembles do slightly different things for the average temperature of the UK. And what I'm interested in is how you reconcile these two. And one way that's been suggested and is done in the IPCC is to use warming levels. And so this is a result of doing it with warming levels. And I don't know what actually is going on, but that doesn't fix it. So that's something that I've been thinking about with my postdoc, Claire, and thinking about uncertainties in that side. I'm based in a geography department. I was in geology and geophysics when I was over here. I'm in the geography department now, and that's forced me to think about humans. And I'm more than happy to talk about various topics of climate change interacting with humans. And I've been involved with thinking about human evolution and pastoralism and the Sahara, and also sort of definitions of the Anthropocene, and whether you might want to pick a definition of the Anthropocene as being sort of when, well, 1610 would be the one, but when Columbus kindly came over and killed all the people in the Americas indirectly, and also stuff with the social cost of carbon. One thing I'm really proud about actually is getting papers cited in all 3 volumes of the IPCC. And so I'm chuffed about that. And that's because I've sort of got involved with thinking of broad things. And the next thing I guess I'm thinking about along those lines is just global warming, is visualizing it. So this is just the global warming stripes I've made. And this is your standard global warming stripes, although we did some awkward stuff about uncertainty to send this back to 1600 as a reference frame, which made it really complicated and it didn't get published because I got too detailed about stuff. But anyway, this is your sort of standard warming stripes on the top. And then this is a population weighted global warming with showing the increase in people, but also including the urban heat island through some quite crude approximation. And the average person is locally living at more than 1.5 degrees now. Even though the world hasn't quite crossed that threshold yet. And so that's that. And obviously, as Cal mentioned, I mainly do paleoclimate, doing Pliocene previously, thinking about permanent El Nino when I was over doing my postdoc. And then when I got my job in UCL, I decided that I'd had enough of permanent El Nino. I think the community might have also decided that it had had enough of permanent El Nino. And so I sort of stopped doing it, but then started thinking about the El Nino bit itself and caring more about ENSO and how that was doing. And that led me to being involved, not ducking fast enough at a PMIP conference. So PMIP is the Paleoclimate Model Into Comparison Project. And I didn't duck fast enough and got assigned with doing a variability working group. And that was what made me host the little workshop that Cal came over. And so that got me thinking about ENSO simulations, and I published something on ENSO in a coordinated series of Pliocene simulations, and it was a real hassle dealing with the data. And so that made me also think about data and moving towards sort of this new phase of Paleoclimate 4. I volunteered to do a simulation with the UK model. The UK model was nowhere near fast enough to actually even run that simulation, so I clearly didn't do it, and decided that my community contribution would be thinking about data and getting data. And that was coming back from this previous work about ENSO, where one thing that regularly happens is somebody will care about what's happened to ENSO and in a model, and you'll want to look at the El Nino or the Nino 3-4 region, say, and to do that, most of the data is already out there, but it's not in a useful format to be able to do that. And so I ended up collecting some time series events, and realizing that actually that collation was a useful thing. And so I guess that's my introduction done when I'm talking about what I'm doing. And now I'm going to shift to something that I've actually stolen these slides, because I did this as a Pages webinar that I will, so that does exist somewhere. But I think what I wanted to point out is really, I just want to say a bit about what model data is already out there. Running a climate model is really onerous and takes a lot of time and a lot of commitment, and spews out tons of data, of which most people, when they're doing a paper, don't care about. And so there's this data that's available that nobody wants, that you know, I've got my paper out of it, but I've got this spare data. And so there is some there's some nice thought about how to share that. And so I'll say a little bit about what data is already out there that is easily accessible, and then go into how you can go about getting it. And that's sort of what I'd like to do to show today, I suppose. When I talk about climate, this is just to remind me that when I talk about climate models, I'm really thinking about sort of weather forecasting models, dynamic models. I do some stuff with people in our Turing Institute on data science, and those sort of empirically based data models are not what we're talking about here with climate models. These are ones that have the physics baked in. And there are decisions within your model as to which bit of the Earth system you're including in your climate model. And this slide is more to remind me that. And so basically, when most of the models, you'll have an atmosphere and an ocean, and you have something to do with the continents, normally just sort of crops growing and dying over the year and the interaction of that. But then with something that's called an Earth system model, rather than a climate model, you'll generally have more dynamical vegetation, so the forests can move on, and those timescales you probably need to run for a good 500 years or more to spin that up. They'll have a sea ice. They might have an ice sheet, but that commits you to running really long simulations or jumping through some serious hoops, as Marcus can attest to be able to get the timescales of those ice sheets in. I don't know of any models that dynamically change orography. And CSM2 has the land sea mask changing, but not sort of, there isn't necessarily mountains growing and that's kind of stuff.
In the context of ice sheets.
Yeah.
But not continental drift.
No. And so, irrespective of quite what's in your model, there's a decision about what the model is, which processes the model is capturing and which timescales it's running over. And that results in you having two different kinds of simulation. But before I talk about the difference between sort of snapshots and equilibrium simulations, it's worth showing some slides that I'm sure some of you will be familiar with, and getting into some nasty acronyms and trying to explain what's going on. So there is, hopefully you're all familiar with the IPCC. There's a series of climate models that in effect support the IPCC, but is officially different and not connected to the IPCC, although the people organizing it is the same. And the process that collects all of that is the couple model into comparison project, CMIP6. And CMIP6 involves everybody running the same climate simulation and everybody running those climate simulations that are most useful for dealing with things and to answer questions. And to be part of this CMIP6, there's some prescribed simulations that you must do. And really going into acronyms, they're called the DEC, the sort of the core simulations. And that is even an acronym that's not even in English, because the K is for Klima. It's a German one, I can't remember what else is. But the rest of these are all of lots of acronyms. And so you run these sort of standard simulations that allow you to, that don't really tell you anything about the climate, but they're really useful for diagnosing what's going, sort of your particular model, and finding some standard useful numbers for your model, like the climate sensitivity is one. And then you must run a historical simulation so that we can compare things to observations, so that we know something more about the models. And once you've done those really necessary things, then you get to run whatever you want with your model under some time frame, and you can do stuff to do with geoengineering. Got a colleague back in UCL caring about that, or most of them are doing what's referred to as scenario MIP. These are the future simulations of under different conditions of the future. And the one I'm involved with here is the Paleo one, which is known as PMIP. And so that stands for Paleoclimate Modeling for Comparison. And this diagram over here is just showing what some of the simulations are, and pointing out that there's bits of PMIP with models that are within CMIP, and there's bits of PMIP with old models, but they're doing new experiments and they sort of sit outside, and you wouldn't want to count them in your analysis of how good this current generation is. So they need to sit in a slightly different place, but they can still participate in PMIP and provide data. And to be in part of PMIP, you must run one of they're referred to as entry cards, but a paleoclimate simulation. And even if you care about, say, the last interglacial, you've got to do one of the ones that we've done before, so that we can sort of track some advance in the models, is at least the plan, if there was advance. And so here are the simulations that are sort of part of the official PMIP 4, CMIP 6, so the ones with the top-notch models. And I've sort of folded them out into two different sections. These top 4 simulations are the deck, so these are the required ones that every single model will do, not just the ones who are doing paleoclimate. And there are sort of 2 different categories, and I suppose you consider them equilibrium climates. And so for the deck, the obvious one is pre-industrial control, and so this is your baseline. And then the other thing for the category 1 is there's an instantaneous increasing carbon dioxide by four times, and then you let the model move towards an equilibrium, and the process by which it moves towards the equilibrium tells you something about the climate sensitivity model. But the paleoclimate ones that are most commonly run and have the most data for are equilibrium simulations, or attempted equilibrium. They're not that long, but what I mean by that is they have constant forcing conditions. So the things driving the climate model are staying the same right the way throughout the run. And so the one I was leading the analysis of was the mid-Holocene simulation. So that's 6,000 years ago. And there is basically an orbital change, but there is a slight reduction in carbon dioxide levels. And then there's and the last glacial maximum at 21,000 years ago. These 2 have been involved in PMIP for the past 30 years. There was a nice virtual 30-year anniversary celebrations. And so these kind of simulations have been done with models for a long time, and we can track how well models are going. This most recent iteration has joined 2 new simulations into the official stable of PMIP. One for the last interglacial, which clearly the last interglacial is a transient period and quite long, but in this context, no, it's 127,000 years ago, that's it. And then there's one focused on the mid-Pliocene, and for some reason, the people setting up the mid-Pliocene added on some extra random letters that know something in the code if you care. But the only one everybody's going to do is this particular one, which is fine to be the mid-Pliocene. And that run has been going on for so long, it's not really even in the middle. It's not close to the middle of the Pliocene, it's right at the end of the Pliocene, at 3.2-ish million years ago. And then there are some other ones, that's referred to as deep MIP, so there are some deep time ones, but the data available for that's less official, and so the data available for that comes through a different thing than I'm going to discuss. There are some transient simulations that are sort of officially approved and coordinated is the important bit about this. There is a last millennium simulation. I'm not going to talk about that because not many people have done it and submitted data for it yet with the new generation. Only about 3 models have, I think. And then there's a long-lasting glaciation simulation that again people have done, but not with the top-notch models.
Hey, Chris, can you just distinguish between what those are, equilibrium and transient?
Oh, yes, sorry. So I thought, yeah, I obviously didn't get to it. Sorry. So if you imagine or if you think of these two, might be the most obvious one. So the pre-industrial control is 1850, and the boundary conditions that the climate's sort of being forced by are just 1850, and then the next year is 1850 again. And so the forcing, so the carbon dioxide levels, the volcanic emissions, the land use is all just constantly 1850 run over and over and over again. And so that's the same with all of these simulations. They're the same sort of, well, the boundary conditions, but the same things that the atmosphere is responding to. And those stay the same, whilst the historical simulation is what I'm thinking of as a transient one. Obviously, that the carbon dioxide levels have been increasing, and we know what they are, and we know when volcanoes went off, and we know sort of some aspects of aerosol loading, and so those are changing with the observations as we go forward, and the climate model is responding to those. So it's something where if you see changes in time, then it could, in these simulations, then it could be the changes in the response, or it could just be the natural, El Nino sort of noise in the model, and there's no way of distinguishing. Whilst if you see changes with time in these, then in theory, it's just the noise in the climate model individually. Does that answer it? Brilliant. Okay. So having said about that, what I'd like to do next is to start off by pointing out a bit about where you can get some of this data. So the data is, well, the acronyms are just going to keep coming, I'm afraid. So the data here is from the Earth System Grid Federation or the ESGF. And that is a big portal that supports all of the data that's been run for CMIP6 and also for some other experiments. And it's, for those of you who are as old as me in technology-wise, then this is a bit like Napster in that it's lots of peer data, and the setup runs with all the model. The data is stored in all these various different places around the world, but you log on to a single node and you can in theory see what's on everywhere. And so there's a single search tool, and I use the British one, which is CEDAR, and you can download data from that and find things. And all there's quite a lot of effort having run for a climate modeling center, having run a climate simulation, then making it into a data set that's useful for others. And that process is known as Seymorizing. And I've forgotten what that acronym means, but it's yet again another acronym with a controlled vocabulary. And what that means is that, say the temperature of the surface in one model is called TAS, and the latitude is called LAT, and it's going to be the same in all the models. So if you write a piece of code that works on one model's data, it will work on all models' data, in theory. And in practice, it generally does. There's lots, the data comes in a format called NetCDF, that there are various tools to open. And for goodness sake, don't try and download all the data because there's far too much of it. So that's sort of saying what there is for the PMIP simulations. Now, I should have updated this and I didn't. So this is a few months out of date, but I don't think there's anything more been added in the interim. So what you're looking at here is the different models that have submitted data for the IPCC or for the PMIP simulations. And each of these different models comes from a different modeling group around the world. And you sort of don't treat them as acronyms, you just treat them as names, because it gets too complicated to try and work out what they all mean. This one here is the UK model, and this one, the model that Marcus plays with. So they've done various experiments. These are the different experiments, and you can see the LGM experiment is really hard to do, and not many modeling groups have done it. There are more slowly coming online. In fact, there might be one more anyway. And then these two runs the last interglacial and this interglacial, I suppose, have had a lot more models run to do to it because it's easier to do. You just need to change the orbit and a couple of greenhouse gas and the like, and then press go and let the model run. You don't need to change your land surface conditions, and you put in your ice and land CMAPs, are generally the really hard bit to do. And then there's some, and then a smaller amount of Pliocene ones. And the numbers shown in each of these boxes, how many data fields are available for each of those. Here, with the UK one, we've not submitted an awful lot of data because the process to do it is so onerous that that poor Charlie, having done the simulations, hasn't really managed to get around to uploading lots of data. But there is more data that I can get hold of and have done some stuff with. So that's what the data is. And I've no idea how much data there is in like the size of data for PMIP. I don't think there's a way of actually telling because it's all federated across all these different nodes that I don't think anybody actually knows unless they try and download all of it, in which case it'll break things. So I thought what I'd do next is try and share a different screen if I can, and I'll see how that goes, and walk through doing some stuff on my computer rather than this. So if I do this, well, I don't, yeah, okay, here. So if I end that show, we pop that in there. Okay.
You should be able to share your screen and still we can get the recording through here.
Okay, right, share. Okay, and then I need to get rid of some random bits.
Yep.
So the data site looks like something like this. This is the Earth System Grids Fed web page, sort of search tool, I suppose, and this one is the CMIP6 one. So unsurprisingly, under the era of what's available, it's only CMIP6. But I think what's more useful is understanding a little bit about what these different things mean. And so I thought I would set myself the target because somebody was talking, I've heard some people talk about the Pacific Meridional overturning circulation in the Pliocene. So I thought we'd see if we can find some data to tell something about that. And so knowing, or the quickest way to be doing that is I know that this is going to involve looking at the PMIP data. So I can open this menu, find some PMIP, and at each step I'm going to press search because then it filters down. That wasn't what was happening earlier. Oh no, it's just being really slow. And it filters down to cut out any unnecessary options in your menu. So I've partly picked, so the next thing I'm going to do is if I do the source ID, God knows why, but that's the name that's chosen for which model it is. I don't know why it's source ID, but the next thing I'm going to do is I'm going to select the Pliocene. And because I remember that only a few models have actually run the Pliocene simulation, that'll cut down lots of options and hopefully that'll pull us away. Okay, yeah. And so I've done the Pliocene and I'm going to pick a model now of the ones that have it. And I'm going to choose EC Earth. This is the one that's, well, this particular simulation has been run in Stockholm, but it's it's a European consortium. And I know that it's going to be something in the ocean. So I can open up the realm and pick the ocean. Okay.
Hey, Chris, can I ask a question?
Yeah.
Following doing it. So if I'm in a different node, like the Lawrence Livermore one, I'm getting like a different list of stuff. So,
Yeah,
so
I know.
can you explain?
It's how they ought to be completely identical, but they never quite are.
Right.
And so it's which ones they've talked to at that time. So it should be the same, but there is awkwardness with it. And if you know that a run exists and it's missing, then it's best to go to one of the key node search pages will have a particular, I suppose, responsibility for showing that particular model.
So you just try different nodes until you find the one that's like, because it
Yeah.
doesn't list CSM here, for example, any of the CSM output in the Lawrence Livermore node.
I don't know why.
Okay.
Yeah.
I think you can click on show all replicas.
That's down here.
And will that will essentially pick up
I think that will show everything that is available on
across
entire.
the nodes?
So.
Yeah. But I think it also shows if the data happens to be stored in two places, then it's also going to show the fact that there's two places and stuff.
That's true. That's where it's marked.
Oh, well done. Good.
Been on that side for that.
Yeah. And so the next bit to look at is going to be to pick a variable. I ought to be doing this. Sorry. Let me make my screen a bit bigger. So then the variables. These are all the variables that you can download. And as you can see, they are all meaningless nonsense, I suppose. You can maybe get a bit more help if you look at something called the CF standard name, which is a formal long name of it. And in this case, it's sort of helpful but I happen to know that the meridional stream function is here. This is meridional. Where is it? It's meridional stream function. And the Y means it's latitudinally averaged or zonally averaged across the basins, and Z means that it's in grid coordinates rather than move to technically latitude coordinates, but that actually doesn't matter much, certainly in this model. And so if I want to now, I can search for this, and hopefully we get down to just a single file. And so there's just a single match, and I can list the individual files that are here. This particular one, they've decided to store each individual year in a different file. Sometimes they'll all be gathered together in a file. And
Why do they do that? That's
because it's easiest, it's whatever's easiest for them to do, really.
that's really easier for them to do than put everything in one NetCDF.
Presumably.
That
I don't know.
baffles my mind.
And then you can just, if you just want a single file, then you can download it through the web by clicking HTTP download. And in my case, joyously, my browser has decided this is dangerous, and so I have to do keep, and then it says, oh, it's a bit dangerous, and then I tell it can keep, and then that has downloaded the file. You can do a bulk download during this thing called wget or other ways of doing bulk downloads, but I'm not going to show you that yet or today. And so I've downloaded the file, and then this comes down in a NetCDF format, which there are various different ways to open it, mainly through code. There's also some clicky browser things, and I've got one called Panopoly that here has opened up my file, and it's showing me what's in my file. So I've pre-downloaded the equivalent run for the pre-industrial control. But these are the different variables that are in the file, and here's the one that's important. And then all of these other bits are the information, the metadata you need to be able to interpret that. And in this particular tool called Panopoly, which is a NASA one that you can download, I can then choose to create a plot of this data straight off, and hopefully it'll just pop up. And so here is the stream function of, here is the that this is, or I can change the basin and that'll get me to the Atlantic stream function. I need to change this to be, I need to change my scale so that the colors show something meaningful. Sorry. No, to 10. So this is going to go to from -20 Sverdrups to 20 Sverdrups. And here is the Atlantic meridional overturning stream function in this particular simulation for this particular year. And if I wanted to look at the PMOC, I could go to the third basin, which is the Pacific. And in this case, I can see that there is a little bit of a PMOC here, actually, which surprises me. It's a very weak one, but I wasn't expecting there to be one. But anyway, there we go. And so that's how you can download one of the sort of raw data files and open it up. Just downloading one's not necessarily that helpful, but nonetheless, it's doable. And that's the process by which you can do it. A more useful thing is to not need to download all of, well, wherever it was, here we were seeing all of these different the number of 200 files. So rather than needing to download 200 files and then create your 200-year average of them, you might just be able to find some of that data already averaged. And there are some variables that have already been looked at. So let me move this out of the way. So the first place to look is going to be the IPCC's interactive atlas. And so in effect, there's an atlas in the IPCC, and there was in the last one, and that atlas has an online tool that looks like this. Let me just move my globe down so I can see it. And I'm looking at the advanced version of this online tool, which means I get more data sets rather than the simple version. And as you can see in this, there's projections of the future, model simulations of the historical period, some observational data sets, and then over here, underneath the fact that I'm talking, is some paleoclimate data. And so there's not an awful lot of paleoclimate data here, but there is some. And so you could look at the variable. I've picked the paleoclimate data. So you can look at the variable and you can see from here that there's actually only the temperature and precipitation changes in this data set. And there are the different PMIP4 simulations. So say you wanted to look at the last glacial maximum, and hopefully this will come out and it'll show, I'm on annual mean here. So this is showing the temperature change on the ensemble mean of the last glacial maximum, and it's colder, which is hopefully what should be right. There is a bit more information than just showing that. If you wanted to download just that ensemble mean global field, you could do so by clicking download, and it will be available in either a netcdf format, which is what the rest of the data sets were, and you can just download this picture itself, or you can download a TIFF that you can open up in something like ArcGIS. There is the possibility of looking at particular regions. So these are averages over certain regions, and these are the regions that there are available averages over. Myself, there's a Madagascar region that I like to pick, and then this will show you the annual cycle and all of the different model simulations that are in this LGM ensemble that, as we said, was only 4 models, and it shows you the change in temperature averaged over that Madagascar region for each of the different models. And so you can extract something helpful here rather than needing to download all the data. I think that's really what I was hoping to show. So that's those 2 sources. Where was I going next? The other place, oh, I'm not going there, that's the answer. I'm going to close that, sorry. Got discombobulated.
You want to go back to the computer?
I think I do. Well, yeah, maybe not. Let's, if this is just going to do anything.
Looks like that's frozen.
Yeah, it does, doesn't it? Okay. So, yeah, let's flip back to the computer. Sorry, it's a bit of a faff. But the purpose of doing the long-winded way is so that there's a recording of it and you can refer back to it later. That's the plan that we were going for. So, we've done that, haven't we?
Yeah. And this thing's getting confused.
Yeah.
There we go.
So, the,
Oh, you know why? You have to stop sharing.
oh, yeah, that'll help.
There we go.
So the other thing, and I won't show it today because I'm talking for far too long already, is there's really common data processes that people might want to do, and say computing the El Nino, the Nino 3-4 time series is something that lots of groups might want to do from this data. And in theory, they would need to download all of the sea surface temperatures and then compute it for themselves, presumably using exactly the same algorithm, although that particular one's fairly simple. And that is quite a lot of effort, especially when chances are that somebody's already done it. And so we'll skip on a couple of slides because I've covered some of this. We've done that. So one of the people who's already done it is me. And so I spent my time preparing for the CMIP or for the PMIP data to come along by building an automated process to once there was data, churn it through and come out with some plots quickly and some helpful plots. And I've adopted a workflow, I suppose, that relies on NCAR's climate variability diagnostics package. And it doesn't really matter what that is. It's just something that does long-term averages and spits out some really common modes and common metrics. And so I decided I was going to do that, and then didn't just download temperature, but made sure I downloaded everything that was relevant for this particular package, which is quite a lot of the surface fields and nothing else. And so I've run this climate variability diagnostics package, and it's really supported the mid-Holocene paper that I wrote, or that the community wrote, I suppose, but I led that one. And there was a paper on ENSO looking at ENSO in all of the PMIP simulations that were available. And we used this same package to create all the ENSO ones. And in doing that, I've also pulled out all of the Indian Ocean dipole, because it's got the Indian Ocean dipole in it. And so that's what me and Cal are hoping to work at, is look at some of the data for this. But like models in general, but I feel that everybody's been really kind donating the model data. And so I felt there was an obligation on me to give back the sort of the computed fields that I've got. And so I've tried to do this in a collective way, and we've published a paper saying what we've done and describing some of this in geoscientific model development. And I've done it, but I've also sort of sent out the data, and so there's data in netcdf files, and each individual model run has a netcdf file attached to it that has all of the data for that particular simulation. And then there's some spreadsheets of some averaged variables and the like. And that's just all freely available. There is also, and I won't show it despite all of the faffing around I did earlier, unfortunately, because I talked for too long. But there's also a Docker container so that you can download the tools needed to run all the notebooks with all the Python packages and some of the data. Just download it and press play, and it will all be installed within some virtual machine on your laptop. And so that's something that's available. although obviously I know my way around this, and that's why I wanted to talk about this data that's available, there are lots of other sources of pre-compiled data that aren't IPCC. And so the CSM Last Millennium Ensemble, for example, has had exactly the same package, the climate variability diagnostics package that's been run on it. And this is just showing the AMO, or probably AMV it might ought to be called, but anyway, it's AMO in this, that's been run. And this is all of the different Last Millennium Ensembles. So these are all run with the same model, but with some different forcings. The crazy acronym that you can't even see on this slide describes what the different forcings are being. But you can download all the data from their website, and so that's available.
Where is this website?
It is NCAR, I don't know, I only find it with NCAR CBDP, but I will work out how to give the actual presentation with all the hyperlinks, because that's sort of the important bit. There are, sort of looking forward a bit more, there are also some things that aren't on the Earth system grid and haven't been officially released, but are around, and people are quite happy to share their data because they've invested their massive amount of time and they've got their paper out of it, even if it's not necessarily published. And so the thing that's happening in certainly the European community, although less over here, is the idea of, rather than doing a snapshot simulation at 6,000 years ago and then a pre-industrial one, actually doing your snapshot doing your run at 6,000 years ago and then running it forward for 6,000 years. And that involves quite a lot of computational effort, but with some of the lower resolution models, it's now feasible. And the German group, there's been a big German consortium, and I was involved in a more international one that's created some of these simulations. And so, for example, so I'm collecting people together to look at AMOC changes in some of these runs, and we've got 4 already. And so this is what you're looking at here is, again, you're looking at the AMOC, and here's sort of the AMOC in this particular model, the French model. And the colors indicate the trend in AMOC over that 6,000 years, computed as a linear regression. And so the IPSL model is showing a slight weakening in AMOC. You can't see the scales. It's not a very big weakening, but anyway, a slight weakening in AMOC. The old trace simulation run with the CCSM3 is actually showing a slight strengthening in AMOC over the time period. And these two models don't show some big pattern, but look somehow the same. And I suspect that's to do with Mediterranean outflow in some way, but I haven't really thought more about it. But these are just 4 runs, and so we started this, and I think we're now up to about 10 runs in the community from many different modeling groups. And so that's nowhere near as coordinated. So they're not even quite the same experiment. They're whatever the people who ran the model decided to choose for their setup. And maybe they wanted to look at year by year volcanic forcing, or maybe they didn't. And they made those decisions. And so these runs aren't the same, but they are quasi available, and they will be more available fairly soon. And so that's what I'm playing with now. And this is just showing the Indian Ocean variability stuff that I'm hoping to talk to with you. And so, although this is actually just from an ENSO paper, but reminding myself that that's what we're planning on doing, is doing some silly scatter plots with lots of models. Each of the different colors on this is a different model simulation. The red ones are the future ones, and the blue is the LGM, and the green are orbitally forced things. And so it's looking at how the variability changes with the mean state across all the different models.
Let's put some data on it.
Yeah.
That's what I was saying.
Yeah. So we wimped out of doing data in this paper because it was big enough already.
You don't want all the data people on the paper. I see what it is.
No, it wasn't that. There was more than enough people on it already.
I'm totally kidding.
But
It's a good paper on its own.
but it's there, and
Yeah.
hopefully, like, you can download, like, the data's there as some spreadsheets, and you can download it and then start putting data on it. I would love it if that happens. And so just to sum up, then I think this is my sort of hierarchy of how you might go about it. The first thing to do to go and get some model data is to see if you can get somebody else to do the work for you, right? And so collaborate, talk to somebody who might already have that data kicking around and can do the plot. They might not, but it's worth the time just to discover whether somebody's already done it. And then I think you want to ask if there's a relevant PMIP simulation, because they are all freely available. You don't need to ask people's permission to use their data. There's no stepping on toes. It's there, it's free. As long as you cite it, it's there. So if there's a relevant PMIP simulation, then that's great. And then you want to start saying, is there pre-processed data that gets to where I want? Do I actually have to do all the work, or can I just find something already there and just plot that and then save myself the effort? And the first place to start is the interactive atlas. And then there's things like my tools where there's some data already around, or you might want to look in a supplement of a published paper. Often modeling groups will put something in there. And so that's the thing. And then the next one is the relevant data on this Earth System Grid Federation. I've shown you how to download a file. It's even easier if you can wangle some what's referred to as server-side compute, where rather than downloading the file and then writing your program to do it, you take your program to where the data is and let them play for all the computing time. This is a European setup where they've got where they allow people to apply. It's primarily aimed at sort of developing nations who don't have the computing power. You can download it. I've shown you how to download it manual. There's a command line tool that'll download it for you if you wanted it in bulk. And that you can just install via Conda. But again, you have to be even more careful about accidentally downloading multiple terabytes. And that's all the stuff that's freely available. The models spit out lots of other fields that people don't bother to put online. I don't think there's any, for example, there's several of these runs have water isotopes in them, but there's no water isotope data on the Earth System Grid. Well, there certainly wasn't. I think the controlled vocabulary is now there to allow people, but I don't think anybody's done it. But the data exists somewhere, and so if you really need it, you can go talk to people who might just be able to give it. And with that, that's sort of my recommended steps. And I just want to remind people that I'm around for ages, well, a couple of weeks at least. I'm up in 503, and I'm trying to remind myself that research can be exciting. So I want to talk to people. Thank you very much.
We've got time for questions. Of course, Chris is going to be around, so we can have more detailed chats and more detailed questions. But if anyone has any questions for Chris right now? Yeah, yes.
So can you get access to a node that has the data so you don't have to download anything? Like, is there a way to just work with this in the cloud, or is that just not how it works?
You can, but it depends on it depends on who's paying for it in some respects. So for me in the UK, I can log on to a machine called Jasmine, and that's literally sitting next to the British data node and can get all of it. If, as you were already showing earlier, there are different bits of data stored on different nodes. And so if you want a complete set, then you probably will need to download it and do it yourself. But sort of NCAR must have a massive replicate of quite a lot of it. And you can just apply for what is for them small beer of compute time. Do you know more, Marcus?
Yeah, they have a lot of future simulations. If you're interested in paleo, I don't think there's anything
On there. So a lot of people basically they're hard copying stuff to some place, and then you have to have access to that place if you want to do it without downloading your computer.
Yeah.
So there's no like distributed cloud option.
No, there is too much data to make that routine. I think there's quite a lot of talk about doing something along those lines. And there is, Ryan Abernathy has a Pangeo set that has runs that people have asked, or there's data that people have asked him to put on there. And I suspect if you ask nicely, and then he might move whatever data you require onto that formatting, and it goes on the, I think it's Google Cloud that it's done with.
Pangeo?
Yeah.
I think it's AWS.
Is it?
Yeah.
But they got given quite a lot of cloud data storage, but that's actually even stored in a different file format that's better for cloud computing. So there's a bit of manual stuff, but that somebody needs to do. But I think there's a willingness to do it if there's a community out there that'll use it.
And my other question is, have you used the valve tool, ESM valve tool at all, which was like what was supposedly used for the IPCC figures, but I don't know. Like some of ours in our chapter were definitely that, but not all of them.
I haven't, because this particular package that I've been using is in theory part of it, but it's just like the ESM valve tool is just a wrapper that says, and now go and run the climate variability one. So I haven't, this particular package I'm using is all written in NCL. And I know there was discussion about moving it to Python at some point, but it's a low priority. And once it gets moved to Python, it will definitely be in the ESM valve tool. That was an intent that didn't get followed through with.
Questions? Oh, so Chris, what is the best way to combine yearly.NCs? Or is, is the wget a way to combine download, and is there?
The way I do it is download them all and then run a command line tool, which is ncat, that sticks them all together. There, you could probably also find ways of opening in them in Python directly as in effect hyperlink as remote files, and load them all as one big bunch. But I sometimes find it easy to just download it and stick it all in one once, throw the rest away.
I'm still baffled by that. Why it seems so cruel.
Yeah. Really.
I have a specific question. Do you have zonal wind in your?
I don't. I've not touched winds, unfortunately. So, yeah, that's something that I don't know any. I don't know off the top of my head anybody who's might have done it.
Yeah, we're working on compiling it right now. I was hoping you could say.
No, I've avoided that and have actually used like different precipitation-based definition of the monsoon, just so I don't need to download zonal winds. But yeah, sorry, can't help. Although if it's mid-Holocene, you might want to reach out to Pascal Brackenau and find out if anybody's looking at it in IPSL, because they might be doing tropical stuff on SPZ and stuff like that.
Any other questions? We have time for maybe one more question for Chris. Okay, if not, let's thank Chris for. Please feel free to reach out to me if you want a slot set up to meet Chris.
Or just potter by the office, and if
Yeah.
I'm in, the
That's
door's
right.
open, come and say hello.
Okay, thanks everyone.
Stop recording.